first speaker is one of my web heroes. She is part of the CSS working group, has been part of bringing dozens of features from idea through into the browser, is part of the technical architecture group, which is the web standards group that is part of the process that reviews different specs for TC39, for the W3C. It's how things get shipped in Chrome. You know, it's very, very cool stuff. And she's also works at MIT doing human-computer interaction research, teaching UI design, and just generally being brilliant. So please welcome to the stage, Lea Verou.
Hello, everybody. Thank you so much for waking up on a Sunday morning to be here. So, without further ado, our story begins back in the ancient 2006 with the appearance of the first CSS preprocessor. Yes, I know there were some like PHP stuff before that, but like the first popular preprocessor. It was called SAS, and it was written in Ruby. And two more appeared in the coming years, Less in 2009, and Stylus, which was written in JavaScript. So, as you probably know, how many of you have used the CSS preprocessor? Pretty much everyone, right? CSS preprocessors are languages that compile to CSS, allowing easier syntax, without that syntax having to be supported in browsers. And and a lot changed in the CSS landscape once preprocessors appeared. So what did preprocessors give us? I would say that the top 3 features that they brought was variables, calculations, and nesting. And yes, I know, there were a lot of other cool stuff. There were mixins as well, and lots of other things. But I think you would probably agree that like these were the top 3. And you might notice that all 3 have something in common. They're all about reuse. Variables and calculations are about value reuse, and nesting is selector reuse. I mean, this is what CSS was desperately lacking, and to some extent still is, reusability mechanisms to make it more maintainable. So let's look at each of these 3. So SAS variables looked something like this. We could define them in a rule, and they were scoped to the braces where you define them, or you could define them on the outside, and then they were global. And you use them like this. They were popular for things like colors, fonts, measurements, all sorts of things. And eventually, when you compiled your SAS code, it produced CSS that looked like this, which was then sent to the browser. And eventually, we realized that, hey, CSS authors really need variables, so we should define them natively in CSS, so they don't need to resort to external tools for this. And we defined a syntax for CSS variables that looked sort of like this. And many people were like, why are CSS variables so verbose and so clumsy? Why couldn't you just specify that $variables work in the same way that they do in SAS? That's so nice and elegant. So to understand why this syntax was different, and we gain something, we lose something. Yes, the native CSS syntax is usually a bit more clumsy, but we also get a lot back for that. For example, in the case of CSS variables are reactive. So they're not just constants that we can set and then reference for like values like colors and global colors and fonts, but actually we can animate them. We can set them with JavaScript. We can change them with media queries, and they just update anywhere. Instead of being scoped to braces, their scoping is much more clever, much more smart. It's dynamic to the element subtree that you're defining them on, because the browser actually has access to that. SAS could never do that, because SAS doesn't know what the local environment is. And you'll see that this kind of thing is a running theme with all of these features. Calculations, for example. This is what SAS calculations looked like. But they had a bunch of issues as well. Like there were only certain things you can do with SAS calculations. it was only calculations that could be done without having any knowledge of the context, any knowledge of what an M resolves to, what viewport units resolve to. Like, it had to be compatible units. So if I tried to, say, subtract pixels from percentages, I would get an error because SAS doesn't know what that percentage would resolve to, so how could it possibly? But once we got calc, once more, the syntax did look more awkward. We had to use a whole function. We couldn't just like throw operators in the middle of our value. But we got a lot in return. It meant that because the browser has knowledge of the context and everything that affects it, this feature could be a lot more dynamic, and we could take advantage of the reactivity of CSS. Like we changed spacing in a media query, everything updates, including calculations that reference this. And calc was widely supported in 2013. We've been using it for like years now. We're soon getting, so one of the things that SAS offered was also color calculations from the get-go. For example, things like a lighten function or a darken function, although these are discouraged these days because this just adds 20% to HSL lightness, which, as Chris said yesterday, is not a good idea. But the thing is, it also means that doing math in SAS needs to understand every color value that we might possibly want to use. So we're not just depending on browsers supporting these values, but also on SAS supporting these values. So if you try to use OKLCH colors and try to lighten them, you will get an error that that argument must be a color because it doesn't understand that OKLCH values are actual colors. Not only you don't have this problem with browsers, because the browser understands what all the color formats that the browser understands tautologically, but also there's a lot more flexibility. Instead of having to depend on a predefined behavior, like just adding or subtracting amounts of lightness, we can select any color format we want and do any math with its coordinates with relative color syntax. So, we want to add, we can do that. We want to multiply, we can do that. We want to do a max or clamp or whatever, we can do that. And again, once more, we get this same reactivity that we get with any CSS variable. So you may be starting to see a pattern here. So to sum up, there are certain differences between preprocessor features and CSS features. They have different strengths and weaknesses, and I mean, there's nothing preventing us from even using them together. Sometimes I use SAS variables together with CSS variables, for example. So in order, CSS has to deal with much stricter performance requirements. Preprocessors only have to run once, split out CSS, and then they're done with it. So anything that runs in speed acceptable for a build tool is fair game. CSS doesn't have that luxury. CSS code can be changed and needs to be rerun multiple millions of times per second, potentially, so it has to be blazing fast. CSS might be changed through JavaScript, through the CSS OM, like on request animation frame, and the browser just has to adapt. It just has to deal with it. The browser cannot complain that, like, hey, you're changing your CSS too frequently. So this means that certain things that are simple for preprocessors are very hard to do in CSS, because the performance requirements are like orders of magnitude different. Also, native CSS syntax is subject to much stricter syntax restrictions. Any syntax we add to CSS has to be both backwards compatible with all existing CSS code ever written, as well as forwards compatible with any possible future CSS syntax we may ever want to add. Can you picture this for a second? We need to anticipate what could we possibly want to add to CSS 15 years down the line and design syntax that would not get in the way. Obviously, it does not always work out. So obviously, backwards compatibility and future compatibility is also a concern for preprocessors, but since preprocessors are a separate tool and they have versioning, things are a bit easier there. And also error reporting. Like, SAS can complain that your CSS is wrong. CSS cannot complain about anything. CSS just has to deal. You can't get an error. It's just CSS has to deal, and worst case, if it doesn't understand part of what you wrote, it has to move on. Also, Another advantage another strength that preprocessors have here, another edge that they have in terms of compared to CSS is iteration speed. It is much faster to iterate on syntax for preprocessors because there's a lot less stakeholders that you need to get to agree. I mean, there's the SAS core maintainers, and as long as they agree about a feature, it can be added, right? Just like every tool. However, when it comes to CSS, adding a new feature requires consensus among the CSS working group. Then it needs someone to actually write a specification, which is not necessarily the same person that proposed it, as you will see later in this talk as well. And then it requires writing tests, ensuring that the spec is implementable. I mean, okay, tests are also a concern for preprocessors. But then you need to convince browser vendors to implement it. And it's much harder to convince implementers across multiple companies, often with different priorities. And I mean, often it might be hard to convince them because something's not implementable, or something is hard to implement, or something like that. But other times it's just a matter of agenda. Like Apple, for example, keeps not implementing PWA APIs because it harms their business model. So there's also all these political concerns as well. And then even if you get buy-in from browser vendors, you still have to wait for it to be implemented across the board, wait for it to be shipped, wait for it to be widely adopted. The length of this process varies, but it's measured in years. It's not measured in anything less than that. I mean, even 2 years for that whole process is like very short. However, so far it looks like preprocessors have a lot going for them, and this is much better, right? But like I said, you gain something, you lose something. So CSS features have context awareness. It knows what the viewport size is, what media queries apply, what is supported and what isn't, what are the metrics of the font being used, all sorts of things. That allows native CSS syntax to be a lot more powerful. Also, as we've said, reactivity. Native CSS syntax is reactive. If anything change, if any of its components change, everything will just update automatically. Preprocessor syntax is just executed top to bottom, just like imperative programming, just like a JavaScript program. And lastly, because preprocessor syntax has to be ultimately compiled to CSS, it is subject to the same implementation limits as CSS. If CSS cannot do something at all, then preprocessors cannot do it either. For example, before CSS adopted wide gamut colors, there could not be a preprocessor plugin that gave you wide gamut colors because there was no way to represent them really. I mean, we could sort of hack them by generating an image with a tagged color profile, but in general, it was hard. Whereas CSS, when we're defining new features for CSS, our only bounds are what is implementable in the browser C++. Don't get me wrong, this is not a competition. Browsers are excellent for prototyping CSS's future, and because their iteration speed is faster, it's a much tighter feedback loop, and they allow us to get feedback from real developers using these features on real use cases. Preprocessors have been awesome for CSS. A lot of these features, we might never have gotten them if it wasn't for preprocessors. So now we've discussed variables and calculations. Now let's talk about nesting, which is our topic for today. How many of you have not used nesting in a preprocessor or CSS? How many of you have not used any CSS nesting in any shape or form ever? I see one hand. OK. So you probably know what I'm about to say here, so I'm going to go through it a bit fast. Look at this code. It's awful, right? It's very repetitive. You can't even tell what's changing in each row. It's very hard to read because you have to parse the part that is common in each selector. You have to mentally understand that these are all part of essentially one component. There is nothing signifying that these are all part of one component. It's just something you have to figure out for yourself every single time you read this code. Nested code, on the other hand, focuses on what matters. It shows you what the relationships are. it abstracts away the parts that are repeated, so you can actually pay attention on the parts that aren't. It means that you can change things without having to change them multiple times. It lets you keep your code much more dry. I mean, sure, there are a lot of ways that you can misuse nesting, but you can also use it for a lot of good. SAS also did things like this, where it allowed you to concatenate actual class names like this, which was useful for BEM and patterns like that. We are not going to speak of this again. This was a mistake. The SAS designers agree that this was a mistake. I'll give you a link to my slides at the end, by the way, so there is a link to the source for this. And for a lot of things I'm going to say, there's links to sources. So SAS designers have recognized that this is a mistake. And also, we probably could not even do this in CSS, because CSS tends to be more token-based rather than text-based, like preprocessors. And we can nest at rules as well, which makes it much easier to specify variations depending on what's supported, media queries, things like that. We could do contextual styling based on what our element is inside. If the ampersand comes later in the rule and the rule doesn't begin with an ampersand, I mean, we could also rewrite that rule to begin with an ampersand. Many ways to do the same thing. So after developers got this for a few years and became used to this, it was like, well, this is obviously useful, so can we adopt it in CSS? Please, 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 please. So in the rest of these slides, I'm going to refer to the SAS syntax, minus the concatenation that we're never going to speak of again, as the Holy Grail syntax, because that was the syntax that we all agreed, or most of us agreed, was ideal. However, there are some challenges in supporting this syntax natively in CSS without modifying it. And to understand these challenges, we need to talk a little bit about how CSS parsing works. I promise it will be short, and I know that for some of you, especially those without a CS background, parsing may be a touchy subject, but try to stay with me. And I promise I designed it so that it makes sense without background on these things. So, very quick CSS parsing crash course. Like, how does parsing work? When the browser reads the characters in your CSS file, how does it eventually understand what CSS you've written? On a very high level, it goes from characters to these intermediate things called tokens, and then to more complex constructs like selectors and declarations and rules. So what are CSS tokens? Parsing in every language always begins with tokenization. Tokens are the smallest meaningful units in a programming language. This is the same across CSS and regular programming languages. Tokens are basically to programming what words are to natural language. Here are two examples of CSS tokens. These are presented with railroad diagrams. Basically, imagine that every character you read starts from the left, and depending on what it is, you go to the right. And if you can parse the whole thing with that diagram, then you have a number token, or same thing with hash tokens as well. And these diagrams are taken directly from the CSS syntax specification. So let's look at an example in practice of how CSS tokenization works. Let's suppose we have this CSS rule. There is a rule with a selector and two declarations. And so we start parsing them left to right. We have a hash token. We saw how it was defined. Don't worry about the details too much. Basically, then we have a white space token. There is a bunch of single code point tokens like these, more white space. This is called an ident token. It's going to be very important. It's basically identifiers, like letters, start with a letter or a dash. Could have letters, dashes, and numbers later on. And then more single code point tokens, more of the tokens that we've seen before, more of an ident. Notice that the tokens are the same regardless of which part of the rule we're in. Like, we have the same types of tokens in selectors, in declarations, everywhere. Here's a new one, a function token, which is the function name and the opening paren. And then we parse we tokenize the argument separately. Here we have a string token, a closing paren, and a semicolon token, more white space, an ident, a colon, which is a separate type of token called the colon token, white space, then a dimension token. And dimensions encompass all lengths, angles, times, everything with a number and a unit. Another semicolon token, more white space, and a closing angle bracket token, which is also a separate token type. So far that wasn't too painful, right? And then these tokens, the next step is parsing, which is the process of grouping tokens into more complex constructs. In the same way that we group characters into tokens, we also group tokens into constructs like type selector, ID selector, and so on. And any value here is a special token that it's just defined to allow basically any tokens with some exceptions, like unmatched parentheses, brackets, and so on. And this is a very simplified version. The full selector grammar is linked in the notes. And we can also refer to other tokens to build even more complex constructs. So you can see that here, depending on, there's two alternatives in pseudo-class selector. Like if we read a colon token and then an ident, we have a pseudo-class. But also, a pseudo-class can be a colon and a function token and anything inside it. And same for the pseudo-element selector, except it also starts with a colon. And so on. So these grammars, at least before nesting, CSS grammars had a very nice property that basically, let's look at something. So if we are starting to if we're starting to parse a selector, like we're looking at the tokens we have and deciding what more complex constructs we have. And again, this is all very high level, very simplified. But if we read an ident token, we know that we have a type selector, right? There's nothing else we can have. Then if we read a hash token, we know we have an ID selector. If we read the period, we know we have a class. Very unambiguous. If we read a bracket, then we know we have an attribute selector. I'm not covering incorrect code here, but like as long as the code is correct, we know what we have. If we read a colon, then we need to also look at the next token. If it's an ident token, then it's a pseudo-class. Again, this is very simplified. There are exceptions, but that's the general idea. If it's another colon, then we have a pseudo-element selector. So this is not by coincidence. This is by design. Being able to determine the construct from the current token, and maybe by looking ahead one token, or a fixed number of tokens is called fixed look ahead, and is a very desirable property in parsers. And the CSS parser specifically, before nesting, was what is called LL1. It means it needs to only look ahead at most one token. So here's what declarations would look like. Note that there are some commonalities here. Declarations can also start with an ident token and a colon, and then like they can have whatever. It's basically using the same sort of tokens as selectors could be. So let's look at this long token stream. What could this possibly be? Could this be a selector, or like that one, or could it be a declaration, like this one? Let's start tokenizing and to see if this could possibly match. So far, it's matching, still matching, still matching, still matching, still. I mean, I'm ignoring white space here. So, like for a lot of these, we're dropping white space as we go. So far, everything matches. So could we conclude that this is a selector? This describes a selector? Probably, but for the lulz, let's try again for this declaration here. So far, this matches, still matches, still matches, still. So what is it then? Is CSS like this elephant parable where if you touch its trunk, it's a snake, and if you touch the back, its tail is a rope, and if you touch its body is a wall? Like it depends on what you're looking at. So not quite, because at least before nesting, we wouldn't even try both rules at once, because we would know, like, either you're parsing a rule or you're parsing a declaration. There's no ambiguity. But even with nesting, eventually, you're going to read something like an opening brace or a semicolon, and you're going to know what you have. So it's not that bad. But it does mean that you've lost this nice fixed look-ahead property that made CSS parsers so performant. Now, you don't know how many tokens you have to read to know what you have. It could be 1, it could be 2, or it could be 3,000. Who knows? So when we started exploring the possibility of adding nesting to CSS natively, this was a non-starter. No browser would implement a CSS feature that would so fundamentally change how CSS parsing works. Remember, CSS needs to be blazing fast. And if you have to backtrack, that's slow. And with that in mind, Tab Atkins, super prolific CSS editor, basically co-edits half of the CSS specs in existence, drafted the first nesting proposal in 2013. 2013, that's 10 years ago, way before most developers started even considering native CSS nesting as a possibility. So what did this look like? Actually, the very, very first nesting proposal, even CSS working group members don't know that it started like this. The very, very first nesting proposal had braces around the nested rules, and then the syntax inside the braces could be basically the Holy Grail syntax. The only difference from the Holy Grail syntax was that you had to include braces around all the nested rules, and you could not have declarations in there. But apart from that, the ampersand was optional. If you didn't have an ampersand or didn't start with a combinator or anything, it implied descendant. It did not cover nesting at rules. So that is another difference from the Holy Grail syntax, but that was just an oversight. The intent was always to allow it. And then 2 years later, Post-CSS plugin allows us to finally use this in our own style sheet. Unfortunately, 3 months later, Tab changes the syntax to what became more known for the next 7 years as the native CSS syntax, and what you might have heard of as this is how nesting will work in CSS. He dropped the braces and made it mandatory that each rule needs to have a prefix, either an ampersand or an @nest rule when that's not possible. And this is what the difference looked like for the same piece of code. So the Post-CSS plugin duly followed and changed the implementation to follow the new one. And I don't know about you, I've used this Post-CSS plugin so many times over the coming years. But what happened in terms of actually adopting CSS nesting in browsers? Well, not very much. I mean, it wasn't quite 84 years, but it sure felt like it. Part of the reason not much was happening was that a few people, including Tab himself, thought that nesting was better served by a Houdini custom rule. How many of you have heard of Houdini or remember Houdini? Not that many, right? Yeah, that was kind of dropped. It was this effort to add APIs to CSS that allow people to make custom CSS syntax. It's kind of an oxymoron for nesting because a custom rule would be extremely verbose, and the whole point of nesting is to eliminate verbosity. Anyway, moving on. So in the end of 2016, I posted a poll on my Twitter asking developers what is their #1 reason for using a CSS preprocessor. Nesting actually came up first, even before variables. And with that, I pinged the working group asking, what's going on with nesting? Can we adopt Tab's proposal? What's preventing us? Crickets. I got responses from some non-CSS working group members, but in terms of actual working group response, it was crickets. Then another ping in 2018 by someone else. Same story. Some responses and enthusiasm from non-working group people, but nothing from working group people. Then Jonathan Neal, who wrote the Post-CSS plugin, opened another ping, also in 2018, and that actually worked. That actually got a lot more engagement and a lot more discussion, and eventually the CSS working group actually discussed this and agreed to adopt this proposal in 2018. So exciting news, right? Things are finally changing, right? Years pass. Nothing was happening. Nobody seemed interested in implementing this. Developers continued using Sass and post-CSS and preprocessors to do nesting. I cannot begin to tell you how many projects did not even need a preprocessor, and the only reason I had a build process at all in them was to be able to use nesting. And then the State of CSS 2022 came, which I actually which Google funded me to actually lead. And with that, there was a question about pain points. By the way, pain points questions are super important for browsers in these surveys. They really help prioritize what to implement. And CSS nesting was the biggest pain point in that question, like by far. I mean, the second pain point is not even a feature. It's Safari, just Safari. Like the actual feature, the actual CSS feature that is next after CSS nesting is has with like 6.2% of respondents. So huge difference, right? So Chrome went from, I don't care about this, to I really want to implement this right now. Filed an intent to prototype, and Elika, who is like the other extremely prolific CSS editor that co-edits the other half of CSS specs, came to me and she was like, Lea, we can't let this ship. This has a lot of problems. This will be used all over style sheets. Having to prefix every single thing with ampersand or @nest is tedious. It's easy to forget. It's noisy to read. Not to mention, it is incompatible with @scope, so copying and pasting will require a ton of fix-up. So we must do something. And by the way, I'm paraphrasing here. This was a video call. This was not actually messages. So this was my recollection from our call. But before I move on, what was @scope? How many of you have heard of @scope? Not that many, right? So @scope solves, it has some similarities with nesting, but it doesn't, nesting is just a shorthand for writing CSS code that we could write before. Nesting actually changes how the cascade works. So you must have run into this. Like, I don't know if remember when you were first learning CSS, like if you were anything like me, I was very surprised to learn that if I wrote something like this, I did not get the expected result there. What color would the links be there? Well, based on the CSS, they will both be plum. And if we flip the order of rules, we don't fix the problem. They will just both be dark magenta. It's not intuitive. Like, proximity doesn't play a role here. So scope actually solves this because it makes proximity part of the cascade, and it just shipped in Chrome. So we had a bunch of breakouts with other CSS working group members, including the co-editor of nesting, and we had general consensus that the syntax needed improvement before it was shipped, and several ideas about how to improve it. So we shared our findings with the CSS working group. The first quick win was that we resolved to allow ampersands everywhere. And if it's outside of nesting, it just maps to :scope. That already improves compatibility with @scope quite a lot, because it means that you can always copy code from a nested block to an @scope block. But it doesn't solve things the other way around. So then a lot of more discussion. There was a period of heavy activity, dozens of proposals, very hotly debated. In these types of discussions, the big barriers to reaching consensus is not just people assigning different weights to the various pros and cons, but also people disagreeing fundamentally about what even is a pro or con. For example, while most people thought that the Holy Grail syntax was indeed the best possible syntax, for others it was a con because they thought it should always be mandatory because it added clarity. So there are three core strategies to resolve ambiguity. One is, and I called them per rule prefix, nesting rules in a block, and parser switch. What do these mean? So a per rule prefix is basically the strategy of the current proposal at the time. Every rule needs to be prefixed with something. That could be the ampersand or @nest, or entirely different things, like an @sign by itself. The second strategy, nesting rules in a block. Remember the very first nesting proposal? That would fall in this category. So there were a lot of proposals around this as well. Some of them were nested inside the rule, like the first one. Others followed the rule. which we will call post-nesting. And others included like at rules, either inside or after, or ampersands followed by a block. There were many, many proposals here. And then the third one was a parser switch, like something that will tell the browser, stop parsing declarations, and after this point, we only have rules. That could be either a dedicated token, like @nest, or like a dedicated @nest rule, or an rule that would occur naturally anyway, or a rule that is prefixed by an ampersand, but only the first one, things like that. So a summary of the pros and cons of each. One big consideration is, do we need to add syntax to each nested rule? Or it's better if it's syntax that you only add once, and it doesn't increase with the number of nested rules. Mixing rules and declarations is also a pro, because it means that it's more flexible, means people can always paste CSS at the end of a rule. How error-prone the syntax is also a factor. Can we reorder things without breaking stuff? Compatible with @scope, one of the major reasons that we started this exploration again. Also, does it increase indentation level? The CSS working group had resolved earlier that we cannot have a syntax that increases an indentation level. So the ones that included a separate nested block were out of the question already. How compatible is it with the Holy Grail syntax? This is a big one. Like, there's still hope that at the time, there was still hope that eventually the Holy Grail syntax might become possible. So can we get there, or does it mean that or is this code fundamentally different? Of these, only some of the parser switch proposals were compatible, but not all, actually. This would be a sort of half check, half not. And also, is there a clear path for the style attribute? Like, eventually, we want to do nesting everywhere that allows declarations, including inline styles. So far, it looks like the rule prefix syntaxes are out of the question, because they require extra syntax for each rule, which makes them very tedious, noisy, all of these things that we mentioned. But what if I told you that we could go with a prefix syntax, a rule prefix syntax that has all the advantages of a rule prefix syntax, but the prefix could just happen naturally in most cases? Like, authors don't have to think about it. It's just there anyway by just writing the regular rules. So that, and there comes what became known for a while as Lea's proposal. So I'm gonna use that for a bit, just for the lulz. And that basically said, anything that is not an ident starts a nested rule. I don't care what it is. Is it like a period? Is it a hash? Is it a colon? Anything that is not an ident starts a nested rule. And any nested rule must start with a non-ident. If your selector starts with an ident, you have to write it in a different way, either by starting with an ampersand or rewriting like the type selector with an is or where or something like that. So it had the most commonalities to the Holy Grail syntax. It fixed most of these issues and addressed most of these considerations. So it got a lot of very positive response. I mentioned that there was some disagreement about whether ampersand should be mandatory or optional. So we ran a few Twitter polls to developers, and most of them wanted ampersands to be optional, even though some of them were not planning to omit them. They were planning to include them everywhere in their code. So, and here's one takeaway from there. Data is amazing for short-circuiting long debates, and even very imperfect data, like Twitter polls, works better than arguing. The more statistics-minded among you may be horrified at the thought of using Twitter polls as a source of data. Snowballing bias, I can hear you crying. But nothing gets you the same amount of data at the same amount of time, and they're still better than pure speculation. So, after a ton of discussion, I think this must be one of that thread must have been one of the most discussed threads in the working group. The finalists were the current spec at the time, obviously, the parser switch proposals, 3 variations of them, Lea's proposal, which was still called Lea's proposal at the time. It later became known as option 3. And the post-nesting proposal with 3 variations as well. And we did discuss it. We had consensus to switch to option 3 after Telcon. The minutes are actually linked in the notes. Even the editor of the nesting spec liked it and said that upon consideration he preferred it too. The spec was updated. The Chrome implementation was updated like a day later. Notice, this was the resolution, 26th of October, 1 day later. And here's a funny thing. 2022 was not the first time I proposed that idea. It was actually June 2018. So here's another takeaway, sort of tongue-in-cheek. If your idea is rejected, maybe try again later. When I proposed it then, Tab Atkins, the same guy that said that he liked it in the previous slides, was like, no, we can't do this. The benefit's not worth it. It's not a good idea. So, a lot changes in 4 years. Apple could not believe that this was a good idea, despite the CSS resolution, so they wanted to run another poll. And even in that poll, option 3 won by a landslide. So we got another final working group resolution to finally formally adopt option 3 once more. So, great news, right? Are we there? Are we there yet? Are we finished? So maybe we should have been satisfied at the time, but we were so close to the Holy Grail syntax at that point, so close. So I was like, maybe I'm greedy, maybe I'm an eternal optimist, but I opened this thread. Can we relax the syntax further with with some ideas about how we could do it? Basically, the core idea was, let's allow backtracking, but minimize the cases where it needs to happen so much that it's basically an edge case. You could call it, yes, you lose fixed look ahead, but you could call it asymptotically fixed look ahead. The core observations that it was based on was, A, we have far more declarations than nested rules, trivially on CSS that doesn't use nesting, but also that holds true even in style sheets that use nesting quite heavily. So it's obvious that a better strategy, if we need to backtrack, is to favor declarations more than rules. And also, not everything that starts with an ident is actually ambiguous. This is just a rule for option 3 to make things simpler. Like, if it starts with a letter, then you have to use something else. But actually, the real ambiguity is more specific, and it's only like 2% of rules or less. So if you start with anything that's not an ident, then you have a rule. We've already discussed this. If you have an ident, then you can look at the other token. Is it a colon or is it something else? If it's something else, again, you have a rule. If it's a colon, then you can look at the next one. Is it a colon? Then you have a rule. If it's anything else, you have a declaration, because you cannot have a colon followed by other stuff in a selector. So basically, the only problem, the only case where this is an issue is if you have ident colon ident. So the strategy is parse these rules as declarations, backtrack if no luck. And this means you have 0 performance impact for declarations, and a small one for like 2% of rules. Like worst case, you just do double the work for 2% of rules. Pretty small. So as you do in these cases, I went to the implementers and asked, hey, is this feasible? Can we do this? Do you think that could work? So Firefox's response was hopeful, gave me hope. This may work. We need more work, more research, but it could work with our parser. But Chrome was like, no, I want to get any syntax specified and be done with it. So NAC, I won't be spending resources on this non-starter for us. It's paraphrased a little bit to make it shorter, but it's actually, it was that tone. And then Apple was basically like, what Chrome said. So it mattered, it helped a bit that Peter Linz, who is a CSS working group member and also co-chair of the tag, was like, if we cannot even investigate whether the Holy Grail syntax is feasible, then I will raise a formal objection, because I think option 3 has some issues if that is the final goal. It's fine as an MVP, but we need to actually try to get there. So despite the feedback from Chrome and WebKit, Tab, Peter, and others refined the algorithm further. Tab actually works for Google, so sometimes you get people from the same company, like having different opinions. And lo and behold, in March 2023, it turned out that once Google actually did research and actually tried to implement this, it turns out it's actually possible. So for years, we were trying to design around the restriction that we did not necessarily need. So one takeaway here is to always question, before trying to do a ton of mental contortion to fit certain requirements that make things hard, question and really investigate whether these requirements are actually needed, are actually necessary, is there a way around them? Take not implementable with a grain of salt. Like sometimes it just means this is very hard and I don't want to work on it. But also, I think it really helped that we were sort of 80% there, like we could see the light at the end of the tunnel. We had this syntax that was very compatible with the Holy Grail syntax, and we just needed to get a little bit further. And sometimes, when you're at 0%, getting to 100% seems impossible. But once you're actually further along, it becomes much more feasible. And also, there are trade-offs that we had to make. Like, the CSS parsing algorithm is much more complex right now. Remember the grammar I showed you in the beginning of the slides? Forget about that. Like, that would not even be accurate as a simplified form right now. There's a lot of, like tab refine the algorithm even further, and like if you have this, you do that, and like scope down the cases of backtracking even more. So now it's much more complex to parse CSS. But what's the advantage? A much better syntax for authors. And that is almost always a good trade-off for any product. Like if you have to shoulder some internal complexity to expose an interface that is easier to use, that is almost always a worthy trade-off. I mean, obviously, it depends on the specifics and like how much are you improving the interface, how much are you increasing complexity. But in most cases, it's a good trade-off. So before I leave you, what is the current state of browser support? Can we use it? Can we depend on it? So actually, I wrote these slides to use CSS nesting natively. Usually, I used post-CSS for my previous slides. But this time, so there was no live demos in this talk. I'm sorry if you came expecting a live demo, because my talks are sort of known for live demos. But there was actually one, and you had no idea the whole time, right? It was actually there under the scenes. Like, there's thousands of lines of CSS for these slides. And right now, we are already at 78% of browsers supporting option 3 at least. And for the full Holy Grail syntax, it's only 2% right now. It's the green areas, but it's getting there. So okay, surely we're done now, right? Well, there's still lots to do, but we're on a good path finally. That's it. Thank you very much.
Lea, that was wonderful. If you want to join me here, we're going to shift things around a little bit because we couldn't not do a Q&A after that talk. So remember, you can get into the Slido there if you've got any questions. And
oh yeah, if we can put the slides back so that people can see the URL. I don't know if that's changed already.
I think they heard us, so maybe. I don't know.
Okay.
So the first question is there anything from, like you talked about preprocessors at first and the path that got us here. Mm-hmm. Is there anything about SAS or LESS or the other preprocessors that you miss that you think can't be brought forward into CSS?
Well, like I said, I'm an eternal optimist, so I would never say that something will never happen. This is not a phrase that you'll ever hear me say. But there are certain things that are much more challenging to come up with a good CSS syntax. I mean, mixins are an example. Like, we've tried a syntax a few years ago. Those of you that sort of follow standards more, you may have heard of @apply. That was a thing at some point. It was all over the place, and then it just suddenly wasn't, because we saw it had a lot of problems. And since then, we have not really come up with a better mixin syntax. Like, we know that the need is there, but we don't know how to do it yet. But also, even harder than mixins is probably loops. Like, I cannot even begin to imagine how we would do loops in CSS. So there are things like that. And I mean, I do find myself needing loops. It's not like the use cases are not there.
So this is kind of a spicy question from the audience, but it's getting upvoted a lot, so I'm going to ask you. What do you think about Tailwind and the use of inline classes?
Well, I think...
Sorry, this is such a trap question. I'm so sorry.
Well, I think that the politically correct answer is that developers should use whatever makes their team productive. But also, personally, it's with any syntax, it doesn't just matter how efficient it is to write. It also matters how learnable it is when you read it. Because code is read a lot more times than it's written. It's only written once, but it's read many times. So I could not see myself getting behind a syntax that is so nonsensical to read. And basically, without documentation, you're totally lost. If you don't know what these utility classes do, there's no way you can figure it out by yourself. So, yeah.
I mean, I agree. One sad clap from Kyle. Okay, so you talked about early on when you were talking about designing CSS specs how you're looking at it not just for today, but you're trying to predict what might be needed or changed even 10 years in the future. And when you make a change to the spec, that's ostensibly agreeing to support it forever. So how, when you are making these decisions, what's the process that you go through to try to predict that future and try to be ready for what might come in 10 years?
Well, I mean, we do know a lot of the use cases that exist, even if we don't have syntax for them yet. So we might, that does help sometimes to anticipate what might be needed. We know that there's a use case for mixins, even though we don't have syntax for that yet, things like that. We've seen what syntax preprocessors have, so, it's conceivable. It doesn't mean that we commit to supporting something if we take it into account that, maybe down the line we might want to do X. But also, it's something that comes with experience. We've seen things happening, so we can sometimes predict what may potentially happen. When we were designing the new parsing rules around CSS nesting, we had to consider things and I didn't have the time to get into all the details, but another change we had to make to the parser was we had to disallow braces from property values unless they are the whole rule, so that we can still allow things like SAS as shorthand syntax that allows you to set multiple longhands by using braces. We can still do that, but we cannot have braces unless they're the whole part of the rule. They're still allowed in custom properties because we had to add another exception that if the type selector starts with 2 dashes, then it cannot be an element selector. It has to be, it's a custom property. Because it turns out that 2 dashes, that dash something is not a valid custom element syntax. So there was no conflict there, actually. Otherwise, it would not have been possible, because of that.
Cool, very cool. All right, so this is a question about now that we're looking at what CSS is capable of, when would you switch from a preprocessor to pure CSS in a enterprise application? I think a lot of us are building, at a large enough company, we've got big systems and everything in place. When is it the right time to start letting go of those and start reaching for plain old CSS?
That is a good question, because before you said enterprise, I was about to say, well, it depends on what your target audience is. These slides were the first time I could use CSS nesting without a preprocessor, because the audience is basically me. I give the slides around, but it's also other developers that tend to have very recently updated browser versions. So, websites for developers tend to be much more tolerant of you can adopt new CSS features much faster. But enterprise, it depends on the statistics. It depends on what the breakdown is. Not all enterprise is created equal, right? And also, what is sometimes there's a policy around what you can use and what adoption percentage it needs to have. I would look at the market share. Provides percentages of how many users actually have this feature. You can upload, I think, even your own data set, and it tells you what percentage of your own users have this. Also, we're still discussing the supports, the sort of progressive enhancement solution. How could we load a post-CSS fallback for browsers that don't support it? You can obviously do it with JavaScript right now, but the CSS story is sort of less good about this. But you could still have JavaScript that loads like a generated style sheet for these browsers, only if the browser needs it.
Great.
Oh, and last thing, sorry.
Sure.
Even if you cannot use native CSS nesting because of your company policy, breakdown of users and everything, it's still immensely useful for prototyping. Like, you can still use it when you're writing your CSS, even if you have to eventually compile it. And it does mean, like, if you can develop and iterate on your CSS without writing, without having to wait for a build process, that is still a win.
Yeah, I think that's, like, I know that my time at IBM, I didn't get to use a lot of the bleeding edge stuff in production, but it made us much faster at proving out ideas internally and showing somebody how, like, it could work like this, and then we would do the work of figuring out how to backfill it to everything else.
Yeah, I did this when we were iterating on the state of HTML 2023. By the way, you should all take it. It closes on Monday. Browsers are looking at these results, especially the things like pain points or negative sentiment things, to prioritize features. So take it before Monday. It's not just about HTML. It's also about other features. So when we were iterating on the UI, because there were some challenging requirements that we had to work around, I did some prototypes, and I was using, like, container queries and relative color syntax and all sorts of things that we could not actually deploy to the end, to the final product. But they were so useful for prototyping still. Like, we did a user study, and like we used that prototype that I developed because we could tell users in the user study to just have an updated version of the browser. It's not even just iterating locally. Like, sometimes you control the user environment, and it means that you can do things much faster then.
Yeah. So this is a best practices question, which is, it's early for best practices on CSS nesting, but still excited to hear what you have to say. It seems like it will be really useful for things like media and container queries. When do you think it is the right time to use nesting when you're not in a, like, that isn't media or container queries? Like, when are you reaching for nesting outside of, like, nesting your media and container queries inside of a declaration?
Oh, all the time. Like, I think most of my cases are not using, I mean, I do nest utterals as well, but it's basically about keeping a sort of logical unit together without running into, like, scoping issues with, like, classes being global and all that. Like, it allows you to have much more reasonable class names if you follow this consistently, without having to resort to contortions like BEM. And, like, it also helps you structure your CSS. Like, even before I could use nesting, I would indent the rules that were logically supposed to be inside other rules, just so I can read, like, the logical units in a style sheet without having to, like, parse each individual selector, without having to read every individual selector. Like, you scan it and you can see what the units are. Like, if you look at the CSS for these slides, like, there's a talk CSS with, like, and every individual slide that needs, like, its own custom CSS is a rule, and everything that it's styling separately is inside that rule. So, like, it's root level, like, rules for each slide, and it makes it much easier to read.
I have found that as well. Like, even without meaning to, it feels very component-y.
Yes.
To use nesting like that. It's like, this is the component, and here's everything inside of that component.
Precisely.
It feels good. It aligns with how I use everything else.
Yeah, I mean, people are primarily using component to mean, like, web components, React components, Vue components, but ultimately components are any reusable blob of HTML and CSS. Even if you do it manually, it's still a component.
Absolutely. Well, that is all the time we have right now. Thank you so much, Lea. Let's give another round of applause.
Thank you.
All right.